Hey, this is Leach with Simpson Math, and in this video, we will be concluding a discussion of function notation. In the previous video, we talked about function notation and then about the difference quotient and the 3 steps it takes to find the difference quotient. If you haven't checked that video out, make sure to go back and look at it, especially for the part about the difference quotient, because we'll be using it extensively in this video. So let's go ahead and get started with j of x, which is equal to the square root of 2x. So we're going to find just a few evaluations first. So let's evaluate j of 8. So all we're going to do is instead of x, we're going to write 8. So 2 times 8 is 16, and so square root of 16 is 4. So that means that if I plug in an 8 into this function, a 4 is going to pop out. All right, so I would like you to do letter B, j of 4 on your own. All right, so we take the 4 and we plug it into the x, and we end up with 2 times 4, which is 8. If you recall from my square root video, square root of 8 is where we can break it apart into 4 times 2. 8 is 4 times 2, so I can write that as square root of 4 times square root of 2. And square root of 4 is 2, and then the square root of 2 stays behind. So we have 2 square root of 2. So if I plug in a 4, that means out is going to pop a 2 square root of 2. All right? So let's look at plugging in a negative 2. Well, if I plug in a negative 2, then we end up with 2 times negative 2, which is negative 4. And what number can I multiply by itself that gets me negative 4? Well, there's not a number, or there's not a real number that I can multiply that will get me negative 4 if I multiply by itself. So there's a few things here. At the end of the day, there is no actual point that I could graph that would make this work. Nothing real, at least, on a real coordinate grid. So it's imaginary. Now, let me just remind you about imaginary numbers and do a quick little bitty review. If I was to square root negative 1, we define that as I, that little lowercase I, that is the imaginary number I. So we say that the thing that I can multiply by itself that gets me negative 1 is I. So I squared is negative 1. All right, that's another sort of consequence of this. So then I can use this to take the square root of negative 4 and rewrite it as square root of 4 times square root of negative 1. Well, the square root of 4 is 2 because 2 times 2 is 4. And the square root of negative 1, if we're allowing imaginary numbers, is I, because I squared is negative 1. So either of these answers would be acceptable. You'll be aware as we're working most problems what's going on here. I'm wanting you to go ahead and try to see if you can use the imaginary numbers to brush up on that to make sure that you are familiar with those imaginary numbers. All right, so let's do D real fast. So j of a plus b. So I'm going to plug in a plus b, and I get 2a plus 2b, and that's all we can do. So lastly, let's find the difference quotient. So I'm going to take this x plus h, plug it in, kind of like what we just did here. Plug it in, distribute, and we get 2x plus 2h. Whoop-dee. All right. Now we plug in, now we're going to subtract j of x. So when I do that, I'm going to subtract square root of 2x. And that's really all we can do. That's because this is the square roots. Square roots sort of kind of mess things up here. I can't break this apart. I can't break this square root apart here and say, oh, those go away. So because of square roots, we're sort of kind of stuck like this. So that's really all that we can do. And then step 3 is divided by h. Well, because, well, square roots, we can't slash these through. That's not possible. I can't divide those. We're sort of kind of done here. Now, this doesn't mean that anything's broken. If I was looking for the, again, the difference quotient, this is the slope of this line. This works. This is valid. It's just not being able to be simplified. So like I said, most times the stuff will cancel to 0 here. The h's will reduce. But especially like with square roots, not really going to happen, right? Let's move on and take a look at k of x. So k of x is 1 over x, so my x is in the denominator, and then we're going to add a half. So I'd like for you to go ahead and try this one on your own first. So find what's k of 3, not difference quotient. Trust me, I'll do that one for you. We'll do that in a minute. So k of 3 and evaluate k of 3 with this k of x. So pause the video, try this one on your own. All right, welcome back. Let's see how you did. Now, the x is in the denominator here, so that means we're going to have to deal with the fractions and common denominators and all of those things. So I'm going to put my 3 into the into where the x is, which is in that denominator. So now, really all I'm asking is, what's 1/3 plus 1/2? Well, as you recall from my fraction review video, we got to get common denominators. The least common multiple of 3 and 2 is 6. So we're going to multiply this one on the left by 2 over 2. 2 over 2 is 1. And we can multiply the term on the right by 3 over 3, which is 1. The reason why I did that is so that way I'll now end up with denominators of 6. And I'm able to do that because I'm just multiplying by 1. So 2 times 1 is 2. 1 times 3 is 3. Add them together, and now we can say 5/6. All right, let's take a look at letter B. So I'm going to plug in my -5 into the x position, which is in the denominator. Then instead of keeping that negative in the denominator, I'm just going to bring it out front. We talked about this, I think, in the fraction review video. So we're going to just have the negative out front, kind of even with the fraction bar. I could have also written it as a -1 over 5. We often want our denominators to be positive, so I'm going to do it that way. And then for me, when I'm doing my common denominators to figure all that out, I'm going to do it over here on the side. Sometimes I will literally, instead of writing common denominator work, I'll refer to this as side work. And then do my work over here on the side. So if you ever have a little bit of a thing when you're working with some algebra, you go, oh, I need to focus on this one topic or this one skill, or I don't want to take up a bunch of lines just to do some sort of kind of work here, but I need to communicate it to my reader, move it over here to the side. If you move it over to the side, it can sort of kind of be parallel to your work. Be like, here's what I did over here. You can communicate where it went and what happened. This is nice. You'll see me do this a lot, but this is a nice tool to add into your tool belt. So the least common multiple of 2 and 5 is 10. So what multiplies by 5 to be 10? 2. So I'm going to multiply that first fraction by 2 over 2, which is 1. What do we need to multiply by 2 to give me 10? 5. So I'm going to multiply the second fraction by 5 over 5, which is really just 1. 2 times -1 is -2. 2 times 5 is 10. And 5 times 1 is 5. And then again, 5 times 2 is 10. Move those over until we get -2/10 plus 5/10, which is now 3/10. Nothing reduces, so we'll leave it at that. And I, for some reason, have a 5 there. Let me fix that. There we go. -5 and 3/10. Mistakes happen. Even your professor. All right, so let's move on with letter C. All right, with C, again, we'll take the 0, plug it into the x, and so I have 1 over 0 plus 1/2. Now, the reason why I have this question is because I need to talk about 0 versus undefined. This is one of my favorite kind of mnemonics, just things that I use to help me remember things. This helps me remember when 0 divided by something, what that equals, versus something that's not 0 divided by 0, what that equals. I really encourage you to write this down. Lock this away in your memory banks. I remember learning this in sophomore in high school. I was a sophomore in high school when I was in Algebra 2. My Algebra 2 teacher taught me this. It's been stuck with me ever since. So if I have 0 over something that's not 0, it can't be 0, but anything else, that is okay. That's okie dokie. That's perfectly fine. Nothing weird. That just equals 0. But if I have some number that's not 0 divided by 0, that is a no-no. Big old no-no. No. That is undefined. That cannot happen. So in case if for some reason if you get the letters mixed up and you try to do that, that's on. And that's KO. That's a knockout. So on doesn't really make sense, but that's a knockout. That's still undefined. All right. So why does this make sense tangibly? for this to make sense tangibly, I think about pie, not as in that pie, but like a PIE kind of a pie. So my mom makes the best pies. For my birthday, she made, most recently, she made me a strawberry pie, fresh fruit strawberry pie. Oh my God, it was so good. So suppose I took that pie and I cut it into eighths and I cherished every single slice of it. So if there was a pie and I cut it up into 8 slices, that's the number of slices, and on my birthday day, I was like, I want a bunch of them, and I ate 2 of those slices, 2 of those 8 slices, that would make sense, right? And let's say my husband, I'm like, you're not getting any pie, and I'm going to give you 0 of those 8 slices. He just got 0 slices, right? Does that make sense? 0 out of 8. They were pie. They were cut into 8ths. That's the size of the slice. He just got no pie. But suppose I was expecting a pie, wanting a pie, and I was over at my parents' house and I was like, "Oh, Mom, I would love some pie." And she's like, "Sure, I'll give you 2 slices of a pie that doesn't exist because it's not your birthday. I didn't make a pie." So if I was to get 2 slices of nothing, there is no pie. No pie. The pie does not exist. I'm getting 2 slices of nothing. That is not defined. That's not tangible. That's why that's undefined. If there was a pie and it just wasn't cut yet, it would be a denominator of 1 because there's no slices, right? So 0 over something, that's okay. That's just 0. The something, some number over 0, that is a no-no. That's undefined. Lock this away in your memory banks. So what's happening here? We have 1 divided by 0. That's no-no. That's undefined. I don't care about this half. This half is meaningless to me. It is undefined. Can't do anything with this, right? If this was flipped and it was 0 over 1 plus a half, that would be fine. That would just be 0 plus a half, which is all good. That's just a half. Okay, but undefined plus anything is still undefined. It is not defined. It does not have a definition. Okay, we don't have a way to do this, so there is no point to go with this. All right, so let's deal with this difference quotient. So first, let's find what x plus h is. Well, there we go. Replace x with x plus h. Nothing else to really do there. I could work and finagle and get a common denominator here, but it's going to actually end up being harder in the long run. So let's see what we need to do later. So now I'm going to subtract the k of x. And when I do that, so here's my minus k of x. Notice when I distribute, I can go ahead and make those halves go away. So if I would have forced a common denominator here, this subtracting this half would have been a little bit messier. So I've subtracted this half out, but we can keep going. Let's go ahead and add this together. And so when I do, I add this together, I need to get a common denominator. So it's the same idea as before. The least common multiple of x and x plus h is just x times x plus h. So we're going to stick those together, x times x plus h. So this first term has the x plus h. It needs the x. So we're going to multiply by x over x. This is prerequisite knowledge, but I am reviewing it for you. Okay. So then this has an x. It needs an x plus h. So I'm going to multiply by x plus h over x plus h. And then let's distribute. Well, in my denominator, it's going to be x squared minus xh. And the same thing, x squared minus xh, or hx is what I have written. And then x times 1 is x, and this is x plus h. All right, so now let's subtract. So this is this first term minus this second term. So I need to send the subtraction symbol to both of those terms, basically distribute. You could skip this step and go directly to this one here, but I went ahead and showed you that we have parentheses here and we'll be distributing. And then notice that the x's will cancel. So now everything here is in terms of just this one singular h. Nothing else reduces. There's not an h in this first term, so we can't reduce that. So then our last part, as you know, we're going to take this and put it over h. So now we're going to divide. This big fraction bar is division. So I'm going to just rewrite this as division. And when I do, I can say that this is h over x squared minus hx divided by h over 1. I'm going to then change this to multiplication and multiply times the reciprocal. When I do, notice that the h is reduced to 1. And so now we're left with just 1 over x squared minus hx. So I know that's a lot, and it's a bit of a review dealing with all these rational expressions. So that's why I included this one here, just to get our brain going back and how to deal with those fractions, these rational expressions. And we end up with 1 over x squared minus hx. All right, 2 last examples to deal with. All we're doing with these last 2 is just to find the difference quotient. This first one, if you notice, it's just linear. This last one is quadratic. So go ahead and take a second, pause the video, find the difference quotient of both of these, and then we'll go over them. Pause the video, try these on your own. All right, welcome back. Let's see how you did with p of x. So instead of writing just x, I'm going to write x plus h. There it is. I distribute it, and I get 7x plus 7h minus 3. Then we're going to take that and subtract p of x. So I'm going to subtract p of x, making sure to put my parentheses. Here I have square brackets, just because. Distribute that negative. And notice, anything that does not have an h attached to it, I have crossed through them because they've canceled to 0, and we're left with a 7h. And I have put light little boxes around these endpoints. You can maybe put an oval or something. It's not my final answer, but it's just helpful to be like, okay, that part's finished, that step's finished. And then I put my 7h divided by h. H is reduced, and we're left with 7. So there you have it. The difference quotient of 7x minus 3 is just 7, which again should not be a surprise because that's the slope of this line. All right, so now we have this quadratic. Same 3 steps. Find q of x plus h. This time I have a binomial squared, so we have to write it twice and FOIL. So I've written it twice. I did skip the step where I have x plus h, and went ahead and went straight to 2xh. So that's what this is right here, 2xh. And then distribute the 3, and we end up with these 3 terms. Up here I've distributed the negative 8, and ended up with negative 8x minus 8h minus 2. Oftentimes, especially when dealing with quadratics, you get here and like nothing combines like terms, nothing cancels. You're like, oh my gosh. But wait till you subtract the q of x, because then lots of things are going to cancel. So subtract the q of x, distribute the negative, and then you notice that the 3x squared and the negative 3x squared, bye-bye, they cancel to 0. Minus 8x and the positive 8x, bye-bye, they cancel to 0. Negative 2 and positive 2, again, bye-bye, they cancel to 0. So all we have left with are these 3 terms. Notice they all have h's in them. All right, last one, we're going to put it over h, factor out the h, and then reduce it. Again, whenever you do that factoring, I encourage you to do a mental distribution to check that GCF. Is what h times 6x, 6x, xh. H times 3h, 3h squared. And h times negative 8, negative 8h. Negative 8h. Just blurs together, doesn't it? All right, h is reduced, and we're left with 6x plus 3h minus 8. There you have it. That's the difference quotient for q of x. Well, there you go. That's all the examples I have for you. I hope this helped you understand function notation and the difference quotient a little bit better. I'll catch you in the next video, and remember, at Simpson Math, we make math simple.